In this video, we are going to discuss Quicksort, which is another sorting algorithm based on the divide and conquer technique. In the previous set of videos, we saw that in merge sort, we divided the problem into half at every step, which is we were solving smaller subproblems before solving the larger problem. In the Quicksort, we do the exact same thing, but instead of dividing the array or collection into half, we have this idea of partitioning, where we have a pivot element, which is any of the elements in our array or collection. And at every iteration, we'll move all the elements that are smaller to the left of the pivot and all elements that are greater to the right of the pivot. We do this repeatedly till our array is sorted, which is we pick a pivot at every iteration. So the algorithm for quicksort looks like this, which is we partition the elements in the sub array, which is we have this function that is called something like quicksort. And in this, we pass the array along with the starting and ending index, which is 0 and arr.length. And now what happens is we find out a pivot element in the partition method. So we basically first check whether these indices are within bounds. That's what we are doing right here. Next, what we do is we call a partition method that basically returns a pivot element such that, like, after we have called this partition method, our array would have everything on the left that is less than the pivot and everything on the right that's greater than the pivot. Now we recursively apply quicksort to the sub array, which is from first to pivot index -1, because the earlier method is returning the index of the pivot. And then we recursively apply the quicksort to the sub array, which is from pivot index +1 to end. So let's see a quick example here. We have an array. Now what we are going to do is, let's say if we pick the pivot as 7, which is the first element, we stick to the strategy where the pivot will always be the first element. In that case, what we are going to do is, after our first iteration, all the numbers which are less than 7, which is 4, 3, 2, 6, and 5, will be lesser than the pivot. And now the elements that are greater will be on the right side. Next, what we are going to do is we are now going to apply quicksort to this half and quicksort to the other half. So again, like when we call the quicksort, we again pick the first element as the pivot for this half. So at the end, we'll have something like 4, and whatever numbers are lesser than 4, which is we have 4 here, we have 2 and 6 on the left, sorry, 6 and 5 on the right. And then what we are going to do is we are also going to apply quicksort, which is 9 is our pivot, because we chose this strategy that whatever is the first element in the sub array, that's going to be the pivot. So 8, so we'll have 8 on the left of 9, and then we are going to recursively apply quicksort to this element, and then quicksort on these two sub arrays, and so on. So by the end, we will have all the numbers sorted. Now, the key idea here is, like, we can move all the elements to the left and right by having like more memory, but how we can do that by not initializing another sub array or by not assigning any more memory. So we are going to see a common algorithm for our partition method. And how this works is, you remember, like, the first thing that we are trying to do is we are going to partition the original array, and this method returns a pivot, which is we have a pivot as well as the elements in the array where all the elements on the left of the pivot are smaller and all elements on the right are greater. So here are like I'm going to show you how the partition method works in your implementation and how you can build this without consuming more or initializing more memory. So we stick to our pivot approach, which is we are picking the first element as the pivot. You do not have to use this strategy. There are multiple strategies. You can pick the last one. There's a proof that if you pick the median of all the numbers, it's way better than the other ones. Then it could be something completely random. So it totally depends. And that's going to influence the overall complexity of the quicksort. So how this works is we have the pivot element. We are going to initialize up as the next element after pivot and down as the last element in our array. Now what we are going to do is we are going to move the up pointer till we see or we encounter a larger value than the pivot. So in this case, 9 is larger, so our up will move here. Similarly, on the right hand side, what we are going to do is we are going to do something that is opposite of what we did on the left. We are going to move the down pointer till we encounter an element that is smaller than the pivot. So in this case, 5 is already smaller than the pivot. So we stop right here. And now we are going to swap these two numbers, which is we have moved our up and down here. We have found the location. And now we are going to swap these, which is 5 and 9. So you can see we have swapped these, and we are going to repeat the same process till up and down meet each other or they pass each other. So this is what exactly this partition method algorithm is stating, which is we are going to move the up till we pass the down. So we are now going to see what is the next larger element than the pivot. So we are going to move up. 3 is smaller, still keep going. 2 is smaller, keep going. And 8 is the element which is larger than the pivot. Now move the down here. We are going to compare, is down smaller? So that's true. So in this case, we are going to swap our up and down, which is these two elements. And in this case, our array would now look like this, which is we have 6 and 8 right here. We are now again going to move our down here. So down is moved here and up is moved here. But in this case, the algorithm will actually stop because what we are checking is up to the left of down or not in our loop. So now what we are going to do is we have down and up right here. So we are going to swap down with the pivot. So now we have this element, which was our original pivot right here, and we have moved down here. And what you see is all the elements on the left of the pivot are smaller and all elements on the right of the pivot are greater. So this is one pass of the partition method. Now you are going to recursively call quicksort on the subarray which is called ARR, but we are going to now pass the indices 0, comma, pivot index, like let's call this PVI minus 1, and then we are going to call quicksort on ARR pivot index plus 1, comma, the length of the array. So you're going to recursively call quicksort on this subarray and this subarray. And this is again going to go back, like it's going to pick the first element. It will have like up and down pointers right here. And then the same approach is followed as we just did. So just try it at home. In the next video, we are going to discuss the code for the quicksort.